All right, so here is another example that we can look at. This one is about the price for diamonds, and then it also gives you the carat size, which is one of four kind of C's that you get told about before you buy a diamond. I think, if I remember correctly, it's been a while, but you've got carat, so that's the size, how big it is. You've got the cut, you've got the clarity, so how clear it is. And then there's one more C, color, I believe, is the other one. So it's been a long time, but all of that is kind of how you have to figure out what kind of diamond you want to buy. So again, I'm hoping that if you have not typed in all of this data into a new listed spreadsheet, that we go ahead and pause this video until everyone has typed it in. Notice how it has three different kind of tables, but if you look at what I put in here, it's just all one column for carats, so that's the size, and all one column for the price, so I put dollar. All right, so now I want to, the problem says to make a scatter plot and describe the association. So let's go ahead, File, Doc, Insert, Data and Statistics, and you have to determine, is it the size of the diamond that determines the price, or is it the price of the diamond that explains the size? So I think that the size of the diamond explains how much it'll cost. So that means carat is going to be my explanatory, the X variable. So carat, the X variable, the explanatory, and the price or dollar will be the Y. All right, so if you look at this, we should be able to describe the direction, form, and strength based on this scatter plot. And the first thing I notice right away is it looks fairly, it looks pretty linear. Almost, just very little scatter, so it looks very linear. It looks very strong. You see how the dots are not really scattered very much away from each other? That looks very strong. And then it looks positive, going from the smaller sized diamonds are cheaper, and then as you get larger in your size, they're more expensive. All right? So, again, because we said it's linear, it is appropriate to go ahead and move to the next question, which is to make a linear model. So create a model, that's the linear regression model based on this data. So I'm going to insert a new calculator page, so Doc, Insert, Calculator page, and this is where I'm going to make my model. So I hit Menu, Stats, Stat Calculations, and like we did on the previous example, I'm going to go to linear regression, because that's the model we're looking at. And I'm going to use number 4, which is A plus BX. All right, so we said our explanatory is carat, or the size of the diamond, and the response, or the predicted value, is going to be our price, or dollar. All right, again, as I said in the previous example, you want to look where is it saving your regression equation to. This says F1 in case I want to use it later. So I'm going to tab down, hit OK. All right, so for here, this is where I want to write my answer for number 2, for creating a model. So I have my Y value, which is the price or dollar amount, and because this is my Y value or response, it's going to be predicted, so it has the hat, equals the Y-intercept is negative 558.519. Negative 558.519. I know it's a positive slope, so I'm going to write plus, and then my slope is 8,225, so 8,225.06 times carats, or the size of the diamond in carats. All right. Okay, so that is our linear regression model. Now, before I use it, because we know that all models are wrong, before I use it, I must see if it's appropriate to keep going. I've already checked to make sure the scatter plot looks linear. So in my scatter plot here, you can see that it is linear, so it was appropriate to make the model. Now, is it appropriate to keep using the model? So I'm going to hit Doc, Insert, Data and Statistics, and this is where I'm going to check the residuals plot, because I'm hoping that there's no pattern in the residuals. If there is a pattern, that means it's not appropriate to keep going. So I would have to do to re-express one or both of these variables. So I'm going to keep caret down here as my explanatory, but instead of dollar, I'm going to hit stat.residual. And that looks like just a cloud, no pattern, no curves or anything like that. So it is appropriate to use this model. All right, so I'm going to use this model to do all the questions on the backside here. So make sure you flip over. We're going to answer 3 through 8. So here we go. Interpret the slope. Well, the slope was 8225.06. So that means for every increase of 1 caret in the size of my diamond, so for every increase in 1 caret for the size of my diamond, I can expect the price to go up by $8,225.06. Now, since all of our data values, I think, were less than a caret, we could also say for every increase in 0.1 carats, and you would just move the decimal over to one place to the left, you would say, I expect the price to go up $822.51. So whatever you want, I don't care. I usually just keep it with 1 unit up or down, depending on the slope being positive or negative. All right? So that's the slope. Now it says, interpret the Y-intercept. Well, the Y-intercept is negative 558.519. So that would mean that for a caret, that's 0 carats. So we have no carats in our diamond. But if we have no carats, then it isn't a diamond. And we're not going to have a negative price. They're not going to give you money to buy nothing. So that's really confusing. So basically what I write here is that, yes, the Y-intercept is negative 558.519. That doesn't really make sense in this problem. The Y-intercept really doesn't make sense. All right, let's keep going. What is the correlation? Well, if I look at my, let's see, where was that? Right, 1.2, there you go. Or no, sorry, 1.3. You can see that where I found my model, I also have the R for correlation. This is the correlation coefficient. And it says 0.993721. I am not surprised by that at all. 0.99 is very strong. Remember, 1 would be a perfectly straight line. We're not going to get that with real data, most likely. But if you look at the scatter plot, I mean, that looks really tight, really strong, close together. So I am not surprised at all that our R value, our correlation, is 0.993721. Okay, so that's the correlation for the relationship between cost and size. All right, explain the meaning of R squared. Now, I know R squared is one of those that takes some time for students to understand. So I'm going to try again with this context or this problem. So R squared here, and I always use it as a percentage, is 98.7%. So 98.7% of the change in the price of a diamond can be explained by the change in the size of the diamond, or the carat value. All right, so again, 98.7% of the change in the price of a diamond can be explained by the size of the diamond. And that makes sense. I mean, you guys probably have heard all the time, about celebrities. They buy these 2, 3, 4 carat diamonds, and they're really, really expensive. The more carats you have, the more expensive it will be. It's a bigger diamond. Okay, so it's more rare. Now, there still is a small percentage that's not accounted for, right? 98.7 is not 100%. All right, so that 1.3% that's left would be considered or would be explained by those other 3 C's that I mentioned: the cut, the clarity, and the color. All right, so if you ever do get a chance to buy a diamond, you'll look at it with, they'll give you basically a magnifying glass, and you can see the difference between color and clarity. And so you'll have to make that decision, like I did a long time ago, about do I want to sacrifice size for a more clear diamond, or the color is different. Anyway, that's something you'll have to do, or you might do in the future. So that is for R squared. All right. Now, the last question, number 8. Would it be better for a customer buying a diamond to have a negative or a positive residual from this model? The way that I like to do these types of problems is first just write down what is a residual. Well, a residual value is found by subtracting the observed price minus the predicted price, or observed minus expected. Okay? So then I make up prices. So let's say I actually spent $3,000 on a diamond, but the model predicts that I should have only spent $2,000 based on the size of my diamond. So in this case, I paid $3,000, but the model only predicted that I should have paid $2,000. So I overpaid by $1,000 compared to what the model expected me to pay. So this would be a positive residual, and it sounds like that's not a good thing for me because I'm paying more than what the model thinks I should. So a negative residual where I pay $3,000, but the model thinks I should have paid $4,000, that would be good for me as the customer, because as a customer, if I only pay $3,000, but the model thinks I should have paid $4,000, that means in theory I'm getting a deal compared to what the model expects me to have paid. All right? So again, I'm sorry if I'm going fast. I'm just trying to get all of this in so you guys can listen to this and talk to each other about this. This is the process that we're doing for this entire chapter about looking at the scatter plot. Is it appropriate to continue to use linear regression? Check the residuals plot after to make sure that it's still appropriate, and then know how to find and talk about all of these different vocabulary words, okay? So I'm going to stop here for this example.